Okay, when you're doing this first long division, it comes out that the first two terms both cancel. Okay, and that's okay. So you're left with negative 2x squared. You need to drop down both of the next two terms. You have three terms on the outside, so you need to have three terms to divide into the inside. And then it ends up being that our remainder is 0. So this is our quotient. We have no remainder. Okay, did everyone do okay on that one? Okay, so be careful. If you cancel out more than one, you make sure you have the same number. So the synthetic division, remember you have to have those 0 placeholders, just like with the long division. So you had a quartic, it's going to drop down to a cubic when you do your long division or your synthetic division. And our remainder is negative 8. So who remembers a quick and easy way to check to see if we did this correct? Cameron. Pardon? No? No? Plug in a negative 1. Plug in the box number. Plug the box number into the function. Whatever you get out should be the remainder. And that's how you can quickly check, okay? All right. Any questions on long division and synthetic? We're all geniuses on it. Yeah? Today, we are doing section 3-4. Okay, 3-4 is continuing the search for real zeros of polynomials. All right. Let's remember something real quick. If I tell you that 3 is a 0, what's the factor that goes with that? X minus 3, right? Because you set the factor equal to 0 and you solve it. Okay. So the first slide we're talking about taking your roots, or zeros if you will, whatever you want to call them, and writing them as factors. So we're saying x equals negative 1/4, x equals 3, and x also equals 8 over 5. So when I want to write these as factors, you're going to, if it's a fraction, you're going to multiply by the denominator and then either add or subtract the numerator. Does that make sense? So the factor that gives me the 0 of negative 1/4, you're unsolving this. 2 steps. Okay. X equals 3 is easy. It's just going to be x minus 3. What about this guy? 5x minus 8. You multiply by the denominator and you move over the numerator. Okay. We're going to FOIL these together. I don't know if anybody else is bothered that these are green, but we're going to have to change them. Keep my sanity here. All right. It doesn't matter what two you pick. I'm going to pick these two first. So that gives me 4x squared. You can do the O and the I in one step. So you have negative 12 and a positive 1x. It's a negative 11x minus 3. And then we're going to multiply this to 5x minus 8. Same thing. We're going to distribute. So he's done. Our next guy is an 11, so it's going to be negative 55x squared plus 88x. And then I'm going to multiply with the negative 3. And I know you guys know how to FOIL or distribute, however you want to call it. So that's our polynomial. Now, they did ask me for a polynomial with least degree, which means none of these guys are going to have a multiplicity. There's an infinite number of polynomials I can write with these three roots, if you include multiplicities. They also said to have integer coefficients, which is why I did not leave these guys as fractions. I could have written this guy as x minus 8 over 5. But that would cause me to have fractions in my foiling, which I don't want. Okay with that? That's our polynomial. All right. So the second thing we're going to talk about is conjugate irrational pairs. You cannot have just one irrational root. So if I said 2 plus 3 times the square root of 7 is a root, you need to know that 2 minus 3 square roots of 7 is also a root. That comes from that quadratic formula, that plus minus thing. They come in conjugate pairs. It's impossible for an irrational root to exist without his buddy. Okay? His buddy has to be there. If you've got a polynomial with integer coefficients. Okay? Which is what we're going to be dealing with. All right? So, same idea of what we did last slide. But we have to have conjugate pairs. So if I tell you x equals 2/3, what's my factor? 3x minus 2, good. If I tell you x equals 1 plus the square root of 5, both of these guys are positive over here, so when I move them over to the left with the x, they're both going to become minuses, yeah. Right? What else must be a root? X equals 1 minus the square root of 5. So they're not going to tell you both of them. They're going to give you one irrational. You need to know to write the other one. Okay? Important. So, it would be smart to FOIL the conjugates together first. Ignore the guy up front first. So I'm going to get x squared minus x plus x rad 5 for my x. Get negative x plus 1 minus the square root of 5 with my negative 1. Negative x square roots of 5 plus square root of 5. What's the square root of 5 times the square root of 5? 5. So those are my two conjugates FOILed together. We want to multiply the conjugates together because something magical happens. Anything that's irrational is going to cancel. So any radicals you have should go away when you multiply those conjugates together. That's the beauty of conjugates. So you should end up with just a nice quadratic with integer coefficients. And then we're going to bring the 3x minus 2 down and do our final distributing. Now I'm going to go back up and actually read the directions because I didn't read them. I just went for it. It says to write a polynomial with the least possible degree, which again means no multiplicities. Let the leading coefficient be 1. What is our leading coefficient right now? 3. I need to make it a 1. How am I going to do that? Can I subtract 2? No. We have to divide by 3, right? Everybody. Now, if at the beginning instead of writing this factor, I wrote x minus 2/3 and FOIL by it, I would get the same thing. But man, would that be ugly FOILing with fractions. You guys don't like fractions on a good day, right? So use your integer factors, and then if you have to manipulate the leading coefficient, you do it at the end. Okay? Make life easy for you. All right, so that's my polynomial. So I would like you to get your calculators out because we're going to need them for our next slide. So the rational root theorem says possible rational roots are the factors of the constant divided by the factors of the leading coefficient. Those are the only possible rational zeros of the polynomial. Okay? I don't care if you write this example down. I'm just going to talk about it. The next slide, you can write it down. Just make sure you write what the red words are saying. So the factors of 6 are plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. And the factors of 1 are just 1. So that's nice. And you need to divide them all out. So you've only got 4 possible rational zeros. Okay? So if you just had a basic function calculator, such as the little red one, how could you find out if any of these guys are actual zeros? Without graphing it, how do you find that out? I think we just did this last week on Friday. How do I know if 1 is a zero of the function? You can do synthetic division, or you just plug the 1 in, right? If it gives you a 0, it means it's a 0, correct? So how they did it was they would write a list of rationals, and then they would plug them each in to see if it gives me a 0. Or they did synthetic division, one of the two. This is a cubic, right? What can we manage? What can we factor? What can we do a quadratic formula for? Quadratics, right? So if I have a cubic, I just need to know one rational root. And then I can find a quadratic by synthetic division. So that's what we're going to do in this next slide. Okay? We're going to do it all. So, I want you to think for a second. I have a cubic. I want to show you what a cubic looks like. Your hands. This is the end behavior, right? Doesn't that mean I have to cross the x-axis? Okay. So I know I'm crossing the x-axis. I'm either crossing it once, twice, or 3 times. Okay? So, where I crossed 1 time at least, doesn't it have to be rational? Could I cross it 1 time at an irrational location? Is it possible to cross and just have 1 irrational 0? No. If it's irrational, it has to have a buddy with him. He's got to have his conjugate buddy with him. So I know that it's going to cross at a rational 0. All right? So let's figure it out. What are our possibles? So it's going to be plus or minus 1, plus or minus 3. Those are my factors of 3. And on the bottom, the factors of 2 are just 1 and 2. I don't need the plus or minus on the bottom because negatives over negatives, it just gets it all crazy. So if I write these out, it's plus or minus 1, plus or minus 3, those are over 1, plus or minus 1/2, plus or minus 3 over 2. So I have a total of 8 possible rational zeros here. Just looking at this function, it's easy breezy. I can see a 1. If I put a 1 in here, I get 2 plus 5 minus 4 minus 3, which is 0, right? So I know that if I plug 1 in, I get a 0. So 1 is a 0. What's the factor? x minus 1 is a factor. I'm going to do synthetic division with 1. So I have 2, 5, negative 4, negative 3. I drop down the 2. So I know it's a 0. And now I have a quadratic. Guys, I can work quadratics. I can look at this and like, ooh, I can factor this. If I can't factor it, I can put it in the quadratic formula to find some more. So here's my 2 factors. I already had x minus 1 as a factor. So if the question asks me to factor it, I can do that, yes? By just finding one rational 0. Doing synthetic division, getting it down to a quadratic, and doing some factoring. I can write all the zeros. What 0 would I get with 2x plus 1? Solve it. Negative 1/2, and what's this guy? Negative 3, and the 1 we already found, right? So you can find your 3 rational zeros. They're all rational, which is nice. If the first one was rational and nothing else was rational, you can do the quadratic formula to find your other 2 irrational or possibly imaginary roots, just by finding the 1. Okay? Understand how you're going to do it. I want you to, all I want you to do is list. Give me the list of possible rational roots for this guy. We're not going to do a whole question with it. So we're going to do this like we do not have a graphing calculator. And then the next slide, we're going to say, okay, we're in the 21st century, we'll do the graphing calculator. Okay? So I want you to list all the possible rational zeros first. That's the list, right? There's only 10 of them? Any others that I missed? All right. So, since you have a partner, start at 1. One of you do positive, one of you do negatives. Find me the first one that will go in and give me a 0. Yell it out as soon as you find it so that we all don't have to keep going. You're just plugging them in your calculator, plug it into the function, and see which one gives you a 0. We're looking for one that will give me a 0. We're plugging them in. Ah, okay. Bless you. It's not 1. It's not negative 1. It's not 2. Is it negative 2? Okay, so I have a 0. So now it's a cubic. That's only 1 degree from a quadratic. So I only need to do synthetic division 1 time to get that guy down to a quadratic. So let's do it. We're going to put a negative 2 in the box. That's the whole reason we learned synthetic division, not just because it was fun. You're double checking that you get a 0 for the remainder. It tells me we did it right. And we have this quadratic. Now, how do I know, looking at a quadratic, whether it can be factored? Does anybody know? There's a couple quick ways to do it. Anybody know? If you take the AC, if you multiply the A and the C in your head, you get 8. Are there any factors of 8, factor pairs of 8, that in this case subtract to 1? Anything you can think of that multiplies to 8 that subtracts to 1? There isn't anything, so it doesn't factor. Okay, so we are going to do the quadratic formula. Find our other two roots. But this is the factor. What's our other factor? What's our linear factor? X plus 2. So on Math Excel or on the quiz or whatever, when it says factor it completely down to linear factors or irreducible quadratics, this is what it means. That factor, that quadratic factor can't be reduced to another factor, okay? So, quadratic formula. X equals opposite of b, plus or minus b squared, minus 4, times a times c, all over 2a. Those are my two irrational factors, roots, and I also have the -2. It's a cubic, those are the only three I have. So that's not really hard to do, right? It took us a couple plug-ins to figure out where the 0 was. Now, it does get harder the more you have to plug in and try. And I get that. So, this next example we are going to do with our calculator. We're still going to find the rational roots, though. What are our possible rational roots? Now, when you have a long list like this, we're going to want to play with our calculator and try and get something going. Okay? So, we have plus or minus 1. Okay. 1 over 3. 2 over 3. 3 over 3 is already listed. 4 over 3. 6 over 3 is already listed. 12 over 3 is already listed. So there's our possibles. Let's leave them right here. Okay? So we are going to pick up our graphing calculator. And this is not the function that's on there, so we're going to type in a new one. So we have 3x to the 4th. All we want to do is look at the graph. I just want to look at it. I don't want to calculate anything. I just want to look at it. Okay? So, looking at the graph, do you see a 0 that's really, really clear? What is it? 3. So I know 3 is a clear 0. So I know I'm going to use him in my synthetic division. What is not? What can I eliminate as a 0? Is positive or negative 1 a 0? What about positive or negative 2? We already have 3, so negative 3 doesn't work. How about 4s? Positive, negative 4s? Nope. Positive, negative 6s? Nope. Positive, negative 12s? Nope. How about 1/3? There's no negative. This guy, do you see he's closer to the 1 than the 0? So 1/3 are out. Negative 2/3 is out. Positive 2/3, still a possibility. Negative 4 over 3 is a possibility. Positive 4 over 3 is a possibility. So I have, just by looking at my graph, I can tell that 2/3 is a possibility and plus and minus 4/3 is a possibility. Those are the only three you have to plug in. So using your calculator, I can see 3 as a clear winner. Which of the other 3, why do I have to use 2? Anybody know why I need to find 2 of these? Look at we have a quartic. We need it to be a quadratic. So we're going to have to find 2. None of these are double roots. You can look for multiplicities also. There's no double roots here. How do I know if it's a double root? With multiplicity of 2 or 4, it would bounce, right? There's no bounces or jogs, so these are all simple roots. So find me, is it 2/3 or 4/3 or negative 4/3? Plug it in. We have to do it twice. We have to find 2 zeros to use. Is 2/3? Okay. We're going to do synthetic division. You do not have to start with the 3. You can start with the 2/3. I'm going to start with the 3 because that's what I wrote down first. It doesn't matter which order you do synthetic division. So we have 3. Again, you should get a 0 here. So we're going to use those coefficients in our next synthetic division. We are breaking this guy down because right now at this step he's just a cubic. We need him to be down to a quadratic. So 2/3 of 3 is 2. 2/3 of -6 is -4. Okay, make a little star, asterisk. If I have a fraction in the box, you must divide by this denominator, the quotient. So I get x squared minus 2. Okay? So if you divide with a fraction in the box, you have to divide by that denominator. All right. Can you factor that? Could you factor it with radicals? Is that allowed? This could be factored to x minus the square root of 2, x plus the square root of 2. And I'm going to be honest, I don't know how your Math Excel, if they have you go down this far or stop at the top. Let's write our other 2 factors. If 3 is a 0, x minus 3 is a factor. If 2/3 is a 0, what's my factor with 2/3? Yeah, 3x minus 2. Okay. If I want to find my zeros, you already had 3 and 2/3, and we have plus or minus the square root of 2 for my other 2. Conjugate pairs. Okay? So our calculator is going to help us just narrow our focus down and eliminate the zeros we know it's not. Does that make sense? Okay. Let's try one more, just for fun. Okay. Give me a list of all your possible rational zeros. That's what I got as the possibles. Is that what you guys got? So here's another way you can use your calculator. Do you notice that they're all whole numbers or halves? Okay. So when you're using your calculator, instead of graphing this, which you could still graph it, okay, I can still graph it and say, I can see that -3 is before any of them. So I'm going to start my table, maybe, at -3. And if I'm just looking by whole numbers, it tells me -2 is a 0 and 1 is a 0. Okay? I know the rest of them are maybe by halves, so I can hit plus That changes what I'm going by on my table. So negative 2 is a 0, 0.5 is a 0, and 1 is a 0. So you can see them clearly. Okay? Or you can graph it and then narrow them down like we did before. So this is a fifth degree. I have to find 3 zeros to bring it down to the quadratic. So I'm going to do quadratic formula. Let's double make sure that none of these are double roots, are they? Nothing's bouncing or anything like that. Okay. So it doesn't matter. I'm just going to do them in order here. Negative 2, 1/2, and 1. Oh, I divided by 1/2. How do I have to change these coefficients? Divide those numbers by 2. So this is going to be a 1, negative 1. Okay. So our quadratic is x squared minus 3. What are our other 3 factors that we can write from our zeros that we already had? X minus 1, 2x minus 1, and the last one would be x plus 2. Doesn't matter the order. Now notice, if I were to multiply all the leading coefficients in each factor, I would have a 2x to the 5th. That's why we have to divide out that 2, because if not, we'd have 4x. There's all our factors. Our zeros are 1, 1/2, and negative 2, which we already had, and plus or minus what? Square roots of 3. Right? You got to practice doing this. So tomorrow we're going to talk about a sign rule and upper bounds and lower bounds. And then you'll have time to work on math Excel tomorrow as well.